Hello, I will be introducing in the first instance the concept of Agriculture 4.0. So just as with industry where we've seen a transition into digital platforms, we have the same in agriculture. And where you have a machine manufacturing company, we observe 3 phases of digitalization. The first phase would be digitalization of the machine, where, for example, the machine is equipped with sensors and analytics are used to improve the level of efficiency. There's a second phase where the machine environment is digitalized so that the machine interacts with the digital environment and with each other, with other machines. In the third phase, you have the ecosystem being digitalized, connecting stakeholders on the digital platform. There are 4 logics which are followed in digital business models for Agriculture 4.0. And one of these, which we will be focusing on, is networking logic. And examples are the determination, analysis, and simulation of farm management data to improve silo management and, for example, the scheduling of harvesting. And in our analysis, we will be looking at the case from the perspective of the value-added network logic. And specifically, we will be examining patent EP1692929P1, which is a method for regulating and or controlling agricultural centrifugal fertilizer spreaders. And I'll turn you over to King.
Thank you, Erica. The use case presented by the patent is mainly for optimization of the fertilizer application. As we can imagine, during the operation of fertilization in the field, it's pretty hard to distribute the manure evenly in each square of the land. For the rim of the land, it's possible to distribute less, but in the position where the tractor comes across, it's easy to over-fertilization. So thanks to the data of the field, as well as the actuator embedded into the spreader, the switching off and the switching on position can be predefined to improve the efficiency of the fertilization. And the use case here will contribute to achieve the benefits of the data architecture. Furthermore, the data can be transmitted to the community of the agriculture, which might include the provider of pesticide. They can use drone to conduct the crop spraying by the detection of the plants which are in trouble, enabled by the technology of GPS or satellites. And my colleagues will continue and digging deeper about the expanding of the use case.
Thanks there. So as mentioned, we can extend the use case from the use of the field data map, which has the position of the tractor using the sensor in the tractor relative to the field data positions, and for the placement of fertilizer, such that in the third phase of development mentioned by Erica, we create a platform which takes input from multiple sensors to generate a crop growth model, which is based on the digitalization across the farming process. So in this instance, we can take sensors, for example, from the weather, from fertilizer applied and its location on the field data map, the crop that has been sown, and, for example, the soil type, and then look to model that so that we can look over time to determine, based on the crop and the non-crop plants within the field, when an appropriate time is to provide fertilizer to maximize yield of the crops. And then as we monitor insect infestation of the field, when an appropriate time to add pesticide would be to minimize the growth impact on the plant and maximize the effect it would have on an insect. And then further move through to select, based on the weather and the crop growth rate, an optimal time for harvest and harvester availability, and then market prices. Moving forward, as we say, we can utilize the data provided by the different sensors within the growth model to move even past the growth model of the plant in the field and think of possible crop selection for the next year based on soil condition, market prices, and potential weather influences, so that we can then order seed. So this allows us to optimize the full farming process across the crop growth and yield to then get maximum return for the crop that's been planted. We can see then that there's an array of customer benefits creating value across the agricultural process using this platform solution. And Christine will now discuss this in a bit more detail.
So when considering the generic IP strategies which come into play during the digital transformation of traditional farming equipment, we can see that in the patent EP 929, when the system boundaries are the machine, the environment, and the field and the farm, the value added monopoly strategy applies. So in this generic IP strategy, the goal is to block competitive access to the value adding features. And in doing so, the features can support price premiums when marketing the products. So here, what are we selling? The sale of digitalized farming equipment. And with that, of course, as Russell has explained, the benefits from the data architecture come into being. And this then means with the extended use case, we start to create an ecosystem or a network where various stakeholders can exchange the data. And the strategy then can change to a hub monopoly. In a hub monopoly, one starts with the hub or the technology platform, and access to the hub is granted by licensing. So, of course, the value of the network will increase with the number of users, and who in this case will be the users. This will be the pesticide suppliers or the seed producers. And in fact, with the data collected, it could be an endless number of users, which means an endless number of licensees, and that will generate, of course, significant income. And the hub monopoly is a very useful strategy to apply in that circumstance.
So how can we now protect elements of this extended use case? So first we can look at patents, and there we could seek to protect the sensors, the business models, or elements of the technical solution that will also work together with machines, and in turn, like IoT-enabled devices. So for example, machine-to-machine identity, data storage solutions and processing could be playing part, as well as metering solutions and others. We could also think about potentially filing patents for alternative technical solutions that could still be used in practice, but are more there to distract from actually the core technical solution that we would want to employ, which would be used at hand. Then there is obviously copyright that would protect graphics and the user interface. In particular, also the object code of software, the source code would also fall under copyright, but this would be more a trade secret, hopefully, or subject to another kind of licensing strategy there. Then we have the database rights that would also fall into place, especially if we think about, for example, the data that is sort of collected and maybe put into a certain kind of form. Then we have the trade secrets, where that would sort of, our secret sauce would fall in there. So how do the different parts that sort of enable the whole business model or the whole use case play together, considering all the kind of options in the menu that we have. Then algorithms, obviously, hopefully these are not reverse engineerable through the data that we produce. So that's something also that one would need to keep in mind, how to structure that best in an IP strategy. Of the source code we've spoken about already, and my colleague will now talk about designs and trademarks.
Thank you, Astrid. In this part, I'm going to mention trademark and design right. According to the regulation, it is important that these devices are individualized and registered to a trademark to identify machine, ecological method, sensor. The register should not be related to the nature of the product. Also, if the trademark is descriptive or constitute a common term, because it will most likely be rejected. The most important thing is for a brand is a original brand. We will have to look for a brand in terms of digital automation, ideally avoid the commercial name, such as farm, agriculture, etc. For example, Euroscience, Word, Smart Hihoo. And regarding design, it must fulfill a non-technical or ornamental role. It will be very useful regarding what is required. A smaller model or 10 teams, for example, irrigation drones, it has to be an exclusive patented design. It could be protected. It is important that the design make a big difference from other services. For example, improving water capacity or water supply. We could also talk about a method to reuse functional recyclable material that can be used in conjunction with other equipment or technology. Thank you. This was our proposal to protect a little more the use case with EP rights.